Welcome to the inaugural webinar for the National Center for Applied Transit Technology. Framework for Technology Decision-Making is the topic
Cheryl,
we're going to...
Cheryl, you have to start broadcasting.
Oh, I thought you were doing that.
You have to hit the broadcast button. I just started recording.
Welcome to the first webinar of the National Center for Applied Transit Technology. Today we're going to address Framework for Technology Decision-Making. And just to give you a little bit of background about NCATT, we are a technical assistance center that is now having a little technical difficulty. Andrew, can you advance my slide? So NCATT is a technical assistance center funded by the Federal Transit Administration, and we are housed at CTAA, the Community Transportation Association of America, and we are tasked with doing a few things. One of which is doing this webinar series. We have a monthly newsletter. We are very active on social media, on Twitter, Facebook, and LinkedIn. We will be having a series of white papers, and this framework topic will also be addressed in a white paper. And we're generally here for you for rural and small urban transit systems to help them make technology decisions, to show them what technologies are available. And this, and there we are. Next slide, please. And we're generally there for, as I said, for rural, small, urban, and tribal transit systems to help lead the way for them to adopt and make decisions about new technologies. Our first speaker today is going to be Kevin Chambers, and I'm sorry, Andrew Carpenter. My mind is, this whole COVID thing has switched my mind. Okay, our first speaker today is Andrew Carpenter, and Andrew is actually the Deputy Director for NCATT. He's been interested in transit technology for the past 5 years, and he's written about different tech subjects for Mobility Lab, for the National Center for Mobility Management, where he used to work. And he's also done a lot of technical assistance projects in the field for small urban and rural transit agencies to teach them about technology that is available and to help them apply new tools to serve their communities. Okay. Andrew, take it away.
All right, thanks, Cheryl. Welcome, everyone. We're excited to get started and to kick off these webinars. And so we figured that this was a good way to sort of overview the approach that we're going to take when it comes to approaching technology decisions. That's because technology can be sort of a buzzword at this point. And so we want to kind of ground the conversation in how to actually approach and think about technology. And so, I've gotten some requests from people in the past just asking, can you tell us about technology? And that's kind of a broad approach to doing that. So we figured that just figuring out how to start talking about it and then start thinking about it and then going from there is a good way to help people narrow down just that idea of let's talk about technology and then think about what we want and what do we want to accomplish. And so we encourage agencies to talk about what their needs are, what they want to do. And that is also sort of the basis of our technical assistance activities, such as our state summits and our strike teams. And so we also are aware that sadly, many agencies are pretty resource strapped. And so instead of just getting all of the technology, we need to make pretty important decisions about what to choose and the impacts that that will have on the various goals that agencies have. And then one thing that we want to play around with is collaborating agencies. So especially with our state summits, we're going to see how we can bridge different products that places have, and then also how groups of agencies that on their own don't necessarily have a lot of resources could then leverage some of these um, larger impact technologies. And so um, there we go. So my colleague Alex King actually came up with this on one of the projects we were working on with the National Center for Mobility Management. And so this is a great, obviously not scientific approach, but it's a good way to visualize the different ideas that you have percolating within your agency. And so the idea is at this point, you've already come up with a way to address a problem or a goal that you have. And so then you can start to flesh those ideas out and then understand where they fall on these two different spectrums. If it will take a lot of investment, but or it'll be harder to execute, but it will result in a lot of change. You have your top right systemic change idea, or it could be a no-brainer. It's easy to do, and it will make a big impact. Or you won't have to put many resources towards it, but you also won't make a bigger change. And so these are just ways to sort of visualize what you're going to pursue, and then how to choose the different resources, or how to pursue the different tools that you can use based on the resources that you have. And so again, going back to that idea of technology as a large concept sort of being really overwhelming, we're going to work a lot with different agencies on being deliberate and being really focused on what they want to do and then how to go about it. And so that's why this sort of really made sense as the best starting topic for us. And then, the technologies world for transportation is evolving very quickly. And so there's a lot of new jargon coming out that has, I think, tripped people up a lot in the past. And so you kind of have to learn this new vendor speak that's coming out, and then just keep testing different ideas before going all in on a really expensive investment, and then also determine that return on the investment. And so Kevin is going to go um, into more detail about that for us. But I just wanted to sort of introduce that as the general idea and philosophy that we're working off of. So it's not just technology because technology, but because we want to help agencies find the right tools that will help them, push their agencies forward and to better serve the goals that they want to do. So with that, I'm going to hand control of the PowerPoint off to Cheryl and Kevin, and we'll go from there.
Okay, hi there.
Let me
Andrew and
introduce you, Kevin,
go ahead.
before you start, so everybody knows who you are and where you're coming from. Uh, Kevin is in Portland, Oregon, and since 2000, he's been dedicated to assisting public agencies and nonprofits in assuring that their technology investments serve their organizational missions. For 7 years, from 2010 to 2017, he led technology innovation at Ride Connection, a Portland area industry leader in providing mobility options to older adults and people with disabilities. And now he consults through Full Path Transit Technology, focusing on the intersection of technology, mobility, human services, and healthcare. And Kevin as well serves as the technologist for the National Center for Mobility Management.
Great. Thank you so much. And you can hear me?
Yes.
Great. Okay. Well, that's a good start. Well, hi, everybody. I hope you're all well in these really wild times we're in. So the topic here is a framework for making technology decisions. So I'm doing this webinar as sort of a rough sketch and an introduction to a white paper I'll be doing for NCAT. And but this is going to be pretty breezy and pretty fast. But I want to lay some things out, give people some high points, and then give some time for questions and answers. So let's take a look at this. So a framework for making technology decisions. So the first step really is defining a problem, represented here by a broken light bulb. Um, from that problem, you come up with a solution, uh, some different options, some different types of light bulbs that you can get. And you can see that each one of them has its own set of costs and benefits. And so you need to do an analysis of what is the best solution of all the possible solutions out there, select the one that's the best for you based on your analysis, and then you move forward to procuring and you look at the different vendors that provide that specific option and or the solution that you've chosen. Do a cost benefit analysis of those vendors. Select the one that's the best. And then you go ahead and implement and you screw in your light bulb and then you're good. That's pretty much it. I really want to move through this quickly so that we could have times for questions. But not really. Actually, I'm kidding. There's more to it. Um, I mean, I think that model has value, and that's really what a lot of our uh, uh, procurement processes are built around, is that specific approach. And I wish that we could have a world where we are dealing with screwing in light bulbs and things are that sort of modular and clean and forthright. But that's really not what we have. What we have is something more like we're actually, as transportation providers, it's more like we're actually responsible for managing the entire electrical grid. Transportation is complex. Services are complex. We are juggling drivers, vehicles, routes. It's really, there's so many parts and pieces, in the list that we're really not able to get this sort of like nice, clean, pick your light bulb off the shelf sort of situation. So how do we start to think about that? So I just want to list off, I think, what some of the key barriers are um, to applying technology successfully in transit. And I'm going to go through these in the subsequent slides, but these are a half dozen of the high points. One is misidentifying what the problem is, and then underestimating the cost and overestimating benefits. Um, not applying systems thinking and risk management tools, just dealing with too much complexity, um, and then applying sort of a consumer-centered thinking to that complexity, and finally an absence of standards for solving problems. So let's go back to this piece here and just take a look at defining the problem. So defining the problem really is really vital. And I'll start off with this choice quote here from Russell Ackoff, where he says that we fail more often because we solve the wrong problem than because we get the wrong solution to the right problem. I think one thing that I've seen in my work with agencies is sometimes there's just a presumption that technology is a solution right off the bat. Um, I talk to agencies like, well, we need tablets and we don't have tablets. We need an app, we don't have an app. And we never want to start off thinking that our problem is that we don't have technology X. We want to make sure we're digging down to what is it that we really want to be needing, what we want to be doing. Is it about informing our customers? Is it about efficiency of managing changes throughout the day? Where dispatch can more easily communicate with a driver, or we can know where a vehicle is so that we can make last minute changes. We want to get down to that, not to the challenge of, oh, um, we don't have GPS. Well, having GPS itself is not a problem. Um, So, and we want to make sure we're thinking about what the simplest solutions are to that problem and using risk management as a lens for defining problems. And later on towards the end, I'll have a matrix for talking about risk management. Um, so now moving on to developing a solution. Let's just to reiterate, we don't want to be thinking of technology itself as either a problem or even as a solution. So, I think Andrew earlier spoke about, well, what are we even talking about when we're using the term technology? And I think the working definition for my talk, and I think for a lot of people here is just that thing that is technology because it's sort of digital and it's cool, it's new, it's fresh. We don't often think about technology as things like buses, even though really the bus or the sedan or the cutaway um, is really the key technology in transit. It's the thing that makes transit what it is. All these other things, the apps, um, the GPS, none of that is the core technology of our industry. The core technology is the vehicle. And for that, we always want to be having any any of the technology that I think is really like what I'm talking about during my talk here are really is a set of amenities that support and make technology more either more efficient or more usable for the rider. Um, so, and in that, we always want to have the service and the service design lead. Again, it's not about getting shiny objects. It's about making sure the core technology of the vehicle is made as effective as possible. So, and because we're working with this thing that is the sort of the thing that doesn't quite work yet, we want to always be thinking about iterating and learning as we go. Um, we want to be very cautious about technology to try to solve institutional problems, and we want to lean towards simple solutions, as I'll show in these next couple slides. So on the topic of institutional change, I want to take something that's sort of apropos to our moment right here. This is a couple lead paragraphs from a New York Times article from late last month about this fail-safe system to track contagions in China. So China created an infectious disease reporting system. So you can just imagine a large database, a network system. It was going to be world-class and immune from meddling because the system was going to instantly notify government health officials in the central government in Beijing. But it didn't work because the hospitals deferred to local health officials before entering reports into it, which allowed for withholding information, which kept Beijing in the dark and delaying the response. So I added that emphasis, and I want to point this out because here we have a failure of technology, which has had amazing global implications that we're living in right now. And it was because, in part at least, the presumption was the technology was going to solve the problem. And one of the problems was this institutional difficulty of local governments communicating effectively with the national government. And so they said, we're going to just apply some technology that'll take care of that. And then they took their eyes off the problem because they thought they had automated the solution. And that is clearly, we're all paying for that, but there's versions of this, and you may be able to think of them in your own organizations where it just doesn't work. So you want to be very cautious about that, and you don't want to let automation cause, one of the ways we call this is skill decay, where because this system is automated, you're like, okay, it's taken care of. I don't have to think about that anymore. I can put my attention elsewhere. And that is something you really want to be questioning as you explore how technology can help you. So the other thing I want to talk about is managing complexity. And the metaphor that I want to apply, which I'm going to try to dig as much life out of as I can here, is keep your retaining walls 4 feet or lower if possible. So on the left, you'll see something that is higher than 4 feet, and should have been engineered in its design. And you can see here that there's where the wall is getting pushed out, being from pressure on the from the earth, pushing the wall out. And then on the right, we've got a 4-foot wall that didn't require engineering, and it is doing great. It's a brand new wall. These are both taken within about 2 minutes walk of my house. So I've got lots of examples in my neighborhood of where engineering should have been used and where it's wasn't needed because they kept their solution a little simpler. So, and I'll even point out here, because I feel like there's a lot of metaphors I could drag out here, is if you look in the background of the picture on the right, you can see where there's a little change in color on the garage back there. And that's what you can see the height of their old wall and where the earth used to be. So it used to be they needed like a 5.5-foot wall. But when they rebuilt this, they actually removed about 1.5 feet of soil so they could have a 4-foot wall. So it is an understanding in landscape architecture that any retaining wall that is 4 feet or higher needs to be engineered. You need rebar or anchoring or something. You can't just stack up a bunch of blocks and assume that it's going to hold for the long term. But 4 feet and under, it's fine. You basically can stack up a bunch of blocks. So it's interesting to me that when they rebuilt this, rather than engineering it, they chose to actually go through the extra effort of removing soil so they could have a simpler solution. I think this carries out to a lot of the things that we can do in transit, is think about the complexity of our projects. So carrying the metaphor forward, in our industry, when you build your walls 4 feet or higher, what we need is a thing called systems engineering. And that is a complex or an approach where you really dig into all your requirements, and you put a lot of focus on design, and you put a lot of focus on testing so that you know that the thing you're building will actually be successful. Um, and it's the right way to go. And if you can avoid it, that's much better. There's no clear 4 feet guideline in our industry, so it's really it's something that you need to be asking yourself continually as you think about making investments, is are we going into something that's going to need a lot of attention, and you need to bring an engineering framework into it. I think there's some things that you can do that don't require it. Um, and anytime that you can simplify your requirements so that you need either no engineering or less engineering, you really want to consider that. So the one thing I've often heard is like, well, we don't really have to worry about that because the vendor has worked out all the complexities and all the engineering is already built into their solution, and we don't have to really go through that process. And my response is, well, maybe. And I say that because a lot of software, and I'm thinking particularly of things that are really where you're automating the workflows, the internal business processes of an organization, where you kind of have this Rube Goldberg machine where you want a piece of technology that's going to work do everything from client intake to taking requests, assigning those requests to drivers and vehicles, handling the reporting. That's a very complex workflow, and there's a lot of software out there that seeks to support and automate those workflows. But every organization is different, and you really want to dig into how does the software assume that your organization works, and does your organization really work that way? Because it's not that the vendor has gone out and done a survey of all the transportation agencies out there and made their software work with every single one. Rather, the way it usually happens is that they work with one customer, they design something that works for that customer, they move to a second customer, and then they make adjustments for that second customer, and so on and so forth. So you may be different from them. and maybe they made adjustments for your type of operations, but that doesn't mean that it's going to work for you. So it's the there's a lot of details you want to look at when you're managing that kind of complexity. Um, okay, going on to procurement and implementation. Um, as you go forward, if you're doing something complex, you want to think about starting simple. And in the software development world, we have the idea of the minimum viable product, or MVP. Not most valuable player, but minimum viable product. And in that minimum viable product process, you start with the thing that is most important, and then you work outwards so that you get a chance to test out the most important things, and then you start adding other functionality incrementally. But in order to do that, you have to know what's most important. And this speaks not to just to implementation. You can also want to apply this to figuring out what your solution is kind of in the earlier stages. But ranking ruthlessly is very important when you're implementing. Um, and so uh, starting with something small and then building out once you have a foothold is a much better approach. Again, iterating and learning as you go. So the other thing you want to be thinking about in implementation is whether the complexity that you're considering is something that you can manage going forward. I think that's actually the main limiter on technology. Isn't really what we can implement, it's what we can maintain. Um, so that's something to think about, is actually working backwards from where resources you're going to have once everything's in place, and whether you're going to have the energy to really maintain it over time. And so in that uh, vein, I want to offer a risk management matrix here. So the rows are about impact of a particular risk, and then the columns are the likelihood that that risk will occur. And you can see I've kind of color coded them so that the high likelihood and high impact risks is red, along with a couple next to it, and the low likelihood, low impact risks are green, and then we've got this yellow area in between. So going back to that maintenance topic, a high impact, high likelihood occurrence is that you're going to have staff turnover, and that eventually you're going to have some sort of major software upgrade. And because that's both high impact and high likelihood, that is something you really want to be paying attention to and making sure that you have plans for, as well as things that are maybe less impactful, but are also are going to happen, like a minor software upgrade. You want to plan for things that maybe aren't going to be so terrible, but they're more likely to happen, such as the internet access going offline at your office, right? And could take you offline for a while. You want to have a plan for that. And then at the other extreme is, and I'm kind of threw in a hodgepodge of different type of risks, not just technology ones, but for example, let's say you've got a bus barn and you've got motorized doors on that and it fails. That's not likely, and the impact is low because you've got a manual. You can just manually lift it, with a chain or what have you, and that's fine. And then you just call the vendor, when it happens. And you don't necessarily need to have a robust plan for that. And then you've got this gray area in the middle, like a high impact event that is low likelihood, like a global pandemic. Um, that wasn't really likely, but it ended up happening. And so you want some level of planning for that. So on and so forth. I think this kind of ranking and sorting of risks, both when you're planning what your solution is going to be and when you're thinking about implementation and maintenance, this is a really great model to use to help kind of sort through things and figure out what's important, what you need to attend to, and what stuff you can let lie. So this is kind of responses to our initial list of what core problems are, or core barriers to implementing. Is we have digging down to core problems, is really the solution to the earlier problem of misidentifying problems. you really want to take care and analyze costs and benefits, and not sort of put on the rose-colored glasses when you're thinking about solutions. We really have a challenge in the industry in that, again, we're not screwing in light bulbs. We are managing grids. So although we dearly want plug-and-play solutions, oftentimes those are not available for our industry either because our niche is small or because the problem really is just plain complex. We want to be applying systems thinking whenever we can, and that's where uh, systems engineering comes into play. I don't really get to talk about this in any depth because of the kind of the introductory nature of this presentation, but it's something that you really want to be thinking in terms of our technology solutions as systems that interlock rather than lights we screw in. We there's sort of an in-between Lego-like metaphor we can use, but often we're building our own Legos, and so we need to be thinking about those cases and minimizing it when we can, so that we are engineering solutions when we need to, but we're not just going off and doing that and without really realizing what comes with it. So keeping our retaining walls 4 feet or lower if we can. And finally, one thing that I've found, or not finally, next to final, is the idea of cultivating leadership and trade-off based thinking. So, I've interviewed a number of transit leaders around the country, and particularly here in Oregon, and where I've found technology being most successful is where it's also accompanied by leaders who are willing to make tough calls. So, and that kind of goes back to narrowing solutions so that it may be forcing agencies to merge, in the case of one person I talked to uh, at a state level so that the technology solution would be viable. Another is just deciding to have a service design that maybe is a difficult challenge in one sense, but then it allows a whole bunch of, I'll say one thing, for example, is, making a decision to simplify or change a fare scheme. That takes a lot of initial energy to make the change. People are resistant to it, but then if you simplify your fare scheme, that may make e-fare a lot easier. That's something that was done here in Portland. Is we had this really sort of complex and baroque fare scheme, and when we went to e-fare, it went to one fare for no matter the whole zone system was eliminated basically, so that we could have e-fare. But that takes leadership. You have to decide that. You have to lead change and create a vision. You can't just think that the technology will just solve it. And you have to be thinking in terms of trade-offs rather than consumer-based thinking where it's like, oh, the technology, I'll just buy this thing and then that will be my solution. The technology will take care of it, and I that's not a recipe for success, in my opinion. Finally, and we really don't get a chance to go in super deeply on this, but use standards and to support the development of more standards in the industry. So there's a few of them out there that we're leaning heavily on. The General Transit Feed Specification is sort of the oldest and most mature one in transit, and that's being expanded to other things. And the model of the GTFS has been employed by other sort of parallel agencies or parallel industries like bike share. It's been extended into flexible transit through GTFS Flex, so that now we can better describe uh, demand responsive transit and put demand responsive transit into trip planners. All those kind of things are really helping us. There's a lot of standards we don't have and we still need. So one question you always want to be asking vendors is, what's your standards of compliance? How can we use more of them in your solution so that we can uh, get more modularity and more of that sort of plug and play effect, at least incrementally. And I think that covers it. I've got my last piece here. So I think if we take some of these extra considerations into account, then I think we really can. I don't know if we can actually get to rainbows and unicorns. We may not really get to that, but we could be lowering our risk and increasing our success by quite a lot. So um, with that, I'll say thank you, and we can move on to Q&A and anything else that you wanted to talk about, Cheryl.
Okay. Well, I have a few questions, so why don't we start with those? And Andrew, if you could keep up on the chat box and monitor that. It seems to me that there's a lot of areas of technology where there's not a lot of knowledge on the part of the folks in the transit system who may have a problem that they need to solve. And then you combine that lack of knowledge with just a lot of choices in terms of vendors and maybe a range in terms of a technology. Um, and how does someone approach that? It seems like it's it becomes an overwhelming situation, a situation where translation of some kind is needed as well.
Yeah, I think the answer is going to really depend on the type of organization that um, is seeking the solution. So I work a lot with small transit agencies and often very small transit agencies, so highly rural, highly rural and small urban, where there is no IT department. And I think in those cases, uh, the 4-foot rule is very important, that you really don't want to be setting up um,
Ah,
agencies for failure. Can you everyone still hear me? I saw
yes.
the screen share went off, but okay, great. Um, so in those cases, I think probably what they should start off with are things that they can really understand and control, and things like spreadsheets are a respectable form of technology. There's nothing to be ashamed of with spreadsheets. They have scalability problems, right? Like when you get to a certain level, um, they're not really viable anymore. And of course, if you design it poorly, you can get yourself into trouble. Um, but you can go a long way with them, and you can set up, use a online version of a spreadsheet like Google Sheets, and suddenly you have the ability to do some sort of coordination with that spreadsheet. Um, so that's one level, is just work with what you have. I think another level is if you want to actually come up with something that is more robust and allows you to scale up what you're doing, you really should get some help. I think, and there's a lot of ways you can get help. I mean, I think ideally, if you're a small transit agencies, it would be great to have resources either at the regional level or at the state level or through an organization like NCATT or NCMM or RTAP or the others that can provide some sort of technical assistance to help you both understand your problem and understand what's available to respond to that problem in the marketplace. Uh, I think there's also resources, often within communities. There's the company that does something similar, that maybe works with computers or works in logistics or what have you, and maybe you can tap those people to help find some solutions around, GPS or cameras or what have you. But going it alone, I think is a tough problem, to try to go into these specialized tools without support. So, and then going up in organization size as you move to organizations that actually have one or more people who are sort of IT staff, then you want to lean on them, support them, and make sure that they have the resources they need to be able to do the research and do the evaluation, um, and really listen to them on what's the level of resources that we need to be successful with a particular technology. I think that's a quick hit. I don't know if I've answered your question in the way you want it.
Do you think a good solution for figuring out what are good technological solutions and options is to bring in a consultant to be that bridge?
Yeah, yeah, if you can. I mean, I have to admit that that's exactly what I do. So I'm
Okay.
so with that sort of potential conflict of interest stated, yeah, I do think that's what's helpful because, and it doesn't have necessarily have to be someone like me. You can to get an outside point of view, I think can be very helpful because um, it's very difficult to get perspective in your own problem very much often when you're in the midst of it, and sometimes it can just be helpful if you can find the right key volunteer who's a little bit of a techie who can kind of look into what you're doing with a beginner's mind. That's another route to go. It really, I think the larger you go, the more it's important it's going to be to have somebody who's got expertise, and can really focus and break down the problems and do its parts and pieces. At a smaller level, I think if it's a matter of um, a highly rural organization that is just got a few vehicles, there's probably the threshold for what that um, the level of effort to bring in is going to be lower also. But yeah, I think bringing in outside support is can be essential.
Do you see, and Andrew, you can jump in on this as well, more of a reluctance to adopt technology and not know how to approach it? Or folks who see this shiny new thing and say, oh, we've got to have that without really um, analyzing whether that shiny new thing is going to do anything of value?
Andrew, do you want to jump in?
Yeah. So from my experience, the um, groups that I've interacted with, you pretty much you have both, and so there are a lot where a lot of times I have gotten emails or calls just saying, literally, just can you help us figure out technology? We need technology. I'm like, all right, well, we're gonna have to break this down a little bit, and so you have that side of it, and then similarly saying, we heard about this new thing, how do we get it? And so, again, have to kind of walk people back a little bit and say, does this fit into what you want to do? And so there's been a lot of resetting the conversation like that. But at the same time, I've had plenty of interactions where um, it's been very focused on this is what we have done and it has worked. And so we will continue doing this. And so, sort of, and I would never necessarily push something on anyone just for the sake of doing it, but um, every once in a while we will work with them and because they want to do something, and then once it comes to sort of pointing out what needs to be done, then that's kind of where we meet the resistance to trying something different or anything like that. So it's not like I've ever parachuted into somewhere and said you need some technology, but more of a just kind of based off of our conversation, I think this is a direction we should go in, and then that sort of creates its own friction based off of how things have been done and would be done. So that's my experience in a large nutshell.
How do how do transit systems reduce their risk when they're investing in a technology that costs quite a bit, whether that's, electric vehicles or putting in a new scheduling and dispatch system, whatever it is that they feel like they have to get it right because the cost is so high.
So from my perspective, my experience and the work that I've done is more on the sort of customer facing side. And so in that case, there are ways to do low cost tests of it. When I
Can
started,
you explain a little bit about that?
yes. So when I started at CTAA, I was indoctrinated with the human centered design approach. And so there's a heavy emphasis on sort of these lo-fi prototyping activities. And so it can be as simple as you have paper versions of a cell phone application. So you don't even develop the app until you've walked people through and see how they interact with that design. So you can see if the interface and the user experience that you envisioned yourself actually works the way you thought it would, and it works for the customers. In this case, it would be the passengers. Um, or in one of the grantees that I was working with through National Center for Mobility Management, they kind of found a way to make a new system work on the old system that they had, so that way they could work out all of the kinks and make sure that this new concept would work for them, um, and for their dispatchers especially, because that was the bigger concern. And so this way they could know what they needed in the new software before they actually got it developed and launched in their system. And so sort of this scrappy, you could say, kind of approach to figuring out what's needed before you um, implement that new thing. So that's my perspective. As far as the more engineering type things, such as actual buses or computer systems, I'm going to defer to Kevin on that one.
Yeah, I think I would support everything Andrew said, that like I can't speak to electrification of buses. That's really not my area of expertise. Um, but I think for digital technology, for the tablets and so on, I think one is going out and talking to other agencies that are um, doing similar things and seeing how their experience has been is very useful. Um, and having some things you can't really press rewind on easily, right? And so you really do have to um, apply it in engineering, not necessarily hire an actual engineer, but apply an engineering um, mode of thinking to it, and really go through your requirements as thoroughly as you can and come up with what is your concept of operations, which is a sort of term of art, which basically, how is this whole operation going to work? What is the concept behind it? And draw it out, whiteboard it out. I think it takes a lot of to get it right the first time. You need to put a lot of energy in at the front end, probably significantly more than you would like to. And so I think the risk reducer there is a lot of engagement, a lot of thinking things through. And some of it you can do on your own. Some of it, it's really a lot easier if you pull in somebody from the outside who can may have perspective from having worked with other agencies, and just is going to have the beginner's mind with you and could ask questions that you're just not going to be able to think of. Um, so that's an overview of it. On your question about you know whether agencies are kind of more towards avoidant of technology versus sort of seeking it out, I think my experience on that is sort of determined by the prior experience of the leadership. So um, those who have experienced a technology failure and seen it happen are much more likely to have uh, a realistic viewpoint going forward. And those whose experience of technology is mainly framed by an experience of working with consumer grade technology like mobile devices and such, they're going to have the idea that experience is going to map on to sort of an enterprise grade or industry level technology um, solution, and that's where I think is where we're people who have sort of the rose colored glasses and are kind of going, oh yeah, we just need to get this thing, and not realizing the level of effort that it actually takes.
Right. Kevin, could you give us an example or two of the 4-foot rule in your practice in a transit technology example?
Sure, I'll give some ones. I mean, one um, uh, is actually one I'm working on for a highly rural agency, is the idea of rather than setting an agency up with a dedicated scheduling and dispatch system, actually setting them up with a really carefully designed Google Sheets solution that will allow them to do what they need to do um, without needing to have highly dedicated software. So there's some risks there, but there's some real benefits also. Another one is, I think, and this is kind of going back to the idea of thinking in trade-offs, is one way is thinking about how your service design is going to interact with your technology, and thinking about trade-offs. So something that some agencies do is interlining of services, and that's often where sometimes we run into challenges because we have vehicles that are switching between fixed routes, and then maybe at another part of the day they're switching over to doing paratransit or some other kind of demand responsive service, and then they're going back to fixed route. And maybe there's different solutions for fixed route versus demand response. That's the way it is at most agencies. You've got different platforms for that. And there's the challenge of, well, how do we get all these vehicles so that they're all set up both to manage the fixed route technology and the demand responsive technology. And there's some challenges in getting all the apps to work on the tablets and so on and so forth. And frankly, one way to simplify things is to segment your fleet. So you have one type of technology that runs on some vehicles, and then you have a different type of technology that runs on different vehicles. And I've been struck by how much simpler it made some solutions for agencies that do segment out their vehicles um, by service type, how much easier it was to implement things because the switching of um, of modes didn't need to happen. So that's an example of at least a trade-off, and that's not going to work for every agency. Some agencies just plain need that. That's how their fleets work. There's no way that you can assign one vehicle to only one mode. But for those that can, you may be able to say, oh, okay, well then that makes our fixed route deployment and our demand responsive deployments a lot easier. Um, does that make sense? Is that a good example for you?
That does make sense. Um, for a rural agency, a rural or tribal agency that's really not done much in the way of technology adoption, what kinds of technologies do you think they might consider as a first bite of the apple, given the kinds of issues they deal with?
Well, I would start off with, what are their pain points? So is the pain point that they've got 6 different funders, and each has a different reporting requirement, and they need to figure out how to make that sane. Is their pain point communication with drivers? Um, you know, I think I wish I could give a one-off solution, but I would start with where's the pain that they're experiencing, and really look through that and go, why is that painful? Um, and and kind of go really incrementally with like, okay, that's painful because of X, Y, and Z, and then from there you say, okay, well, is that something that can be readily solved? Is there a solution in the marketplace that says, oh yeah, that can be solved with GPS, for example? So now you know where the vehicle is. That great, that might be, but I'm really hesitant to say like this is the thing that is gonna like be the brass ring
Right,
for a solution,
right.
because it kind of goes back to that you know, the fail-proof solution from China, right? Like, well, are you trying to solve an institutional problem? Is that where the pain is? Maybe what needs to be done is maybe really it's additional training, you know, or maybe it's, you know, addressing something else going on in the organization at a cultural level, that's preventing, you know, things from working well. So I wish I could give a single one, and I'm hesitant to do it.
Do you or Andrew have any advice for choosing vendors, whether that's things to avoid, sort of, flash points that should alert you that something is wrong, or a a method for choosing when you're dealing with technologies that you don't know that much about, where you're really relying on the vendor to help create that path to the solution?
We're in an, I think probably the biggest risk I'm seeing right now is there really isn't sort of a technology resource, strong technology resource in the industry to support trans agency leaders at the small level. So if you're at the agents at the level of like a metropolitan area and you've got IT departments, they're able to sort of be effective resources to their decision makers. When you get down to the small urban and rural providers that don't have IT departments, the lack of technical assistance resources, I think, is a really big problem. And so when you have agencies that are experiencing real pain and real problems and they want a solution, generally they're talking directly to vendors. They're going to a conference, there's vendors at that conference, you talk to 2 or 3 of them, they tell you their version of what they can do, and they're not telling you the costs. They're selling you on the benefits, but they're not able to give you a realistic picture of what the costs are, and because that's not their job. Their job is sales. And I think that's the biggest risk, is talking directly to vendors and then almost exclusively to vendors and moving forward with the decision from there. um, you really want to be talking to other agencies. You want to be able to get an outside perspective if it's a significant investment of time and energy, where you get a viewpoint of somebody who is on your side as an agency, and not whose interests aren't with the vendor themselves.
Right. Well, Kevin and Andrew, thank you very much for speaking today. I think this is really helpful for those in the field. And Kevin, we look forward to your white paper. We will certainly uh, blast that out when we get it. And I hope that everyone out there stays well and is doing their social distancing as much as possible. And thank you to all the transit heroes out there as well, who